A research buoy bobbing near a pier moves in a smooth sinusoidal motion. The buoy's total vertical travel, or the diameter, is 4 meters, and it completes one full up and down cycle every 60 seconds. At its lowest point, the top of the buoy is 5 meters above the water line. All right, which of the following equations represents the height h of t in meters of the buoy as a function of time t in seconds, assuming the buoy starts at its lowest point when t equals 0? Okay, all right. We're going to follow at its lowest point means it's going to at least look like this. So let's deal with one thing at a time before I really look at the numbers. Okay, it's going to start at the bottom and go up and down and up and down and up and down. So what we're going to do is we're going to view this as a negative cosine because it starts at the bottom, which is the opposite of the top, and not in the middle. So we are going to treat this as the negative cosine that it is. So let's get rid of a and b. So we're going to compare it to, I guess we'll use the h of t. Why not? H of t equals negative a cosine, parentheses. Since we're not going to move left or right, we only have to worry about b times t. We're not going to worry about minus c's or anything like that. And then we're going to add the midline, which is d. Okay, now this, of course, is written in a little out of order. Who cares? All right, now let's go back to some of the numbers that we needed to focus on, pay attention to. The total travel is 4 meters, which tells me that the total height is 4 meters, which tells me that its amplitude is going to be half of 4. So A is going to be 2. So what we have so far is negative 2 cosine. Now B comes from frequency. And the frequency is the period that you have over 2 pi. Okay, so what do we know about it? Well, it completes one full up and down cycle every 60 seconds, which means the period is 60 seconds. So the frequency, this b, is going to be 2 pi over the period, which is 60, which simplifies out to pi over 30. So b is pi over 30, and then we'll attach t to it. D is the midline. Now, at the lowest point, the top of the buoy is 5 meters above the water line. Well, if it's going to be 5 meters at its bottom, be 5 meters above, right? So you would be 5. That means at the very tippy top, it's going to be at 9. My midline is going to be directly in the middle of that, and without doing a ton of math, we know that between 5 and 9 is 7. So we could put plus 7 here, and that wraps up my equation. Now, they don't want us to word it out this way. For whatever reason, this is worded out with the midline first. So we will say h of t equals 7 minus 2 cosine pi over 30t. And that's going to be U. C for the ocean. Oh, very good.